Very good morning to all. My name is Dr.E.Purushotham. Today I am going to discuss about wave and oscillations. First of all, I am asking what is wave, what is oscillation? Do you know about wave or about oscillation? So I am going to discuss what is wave. Wave is a disturbance that transfers the energy from one location to another location through matter or space with little or no associated mass transport. You can observe on the screen. So this is you observe here, this is the disturbance point. From this point, the wave is a disturbance. The disturbance transfers the energy through matter or space from one location to another location. You can observe here. So one location to another location, it transfers the energy. You can observe this is the starting point. So wave starting point, we can observe here. This is wave is a disturbance that transfers the energy through matter or space with little or no associated mass transport. So in this wave, just the wave is a disturbance that transfers the energy through matter, but the matter is not transferred from one place to another place. The matter is not transferred from one place to another place or one location to another location. You can observe here. So this red particle, for example, it is a starting point. So it is a starting point. So it is moving from this place to same, it will reach the same point, this point. So we can observe from this figure, from this oscillation, we can observe the wave transfers the energy without transferring the matter. So this is the position of particle in an ocean wave or water wave. You can observe clearly the energy transfers from one location to another location. This is the disturbance. The disturbance transfers only energy through one location to another location, but the matter is not transferred from one location to another location. So what is oscillation? Anybody, can you tell what is oscillation? So oscillation is a repeating and periodic disturbance. It moving through medium or space. What I am saying, oscillation is a repeating periodic disturbance. But what is wave? That is the disturbance transfers the energy from one location to another location. But what is oscillation? The energy, or it is the repeating disturbance. You can clearly observe wave is a simple disturbance, but it is repeating and periodic disturbance is called oscillation. So the perfect definition I am going to give, oscillation is repeating and periodic disturbance moving through a medium or space. You can see on the screen clearly. So a repeating, here you can observe, I am giving here. So this is the right symbol. This is also, I am giving this symbol. So this is the center point. This is the center point. The wave is moving left side and also right side. You can observe clearly. It is repeating and periodic disturbance moving through the medium. You can observe clearly here. This is the oscillating wave, that is electromagnetic wave, example of oscillation. You can observe here, this is the center point. This from center point to left side and also right side, it is moving. This is the electromagnetic wave oscillation. A repeating and periodic disturbance moving through a medium or space from one location to another location is called oscillation. But wave, that is a disturbance, it transfers the energy from one location to another location. But oscillation, that is repeating and periodic disturbance. Both are disturbance. But what is the main difference? Oscillation is repeating and periodic disturbance, but wave simple disturbance that transfers the energy from one location to another location. What are the examples of oscillations? You can observe on the screen, that is electromagnetic wave and also mechanical wave. So this is electromagnetic wave. You can also observe this is the mechanical wave. So you can observe that blue particle, it is moving from one location to another location. It is giving repeating and periodic disturbance. So this periodic and repeating disturbance moving the energy through medium or space. This is the example of mechanical wave. What is periodic motion? We are seeing here a repeating and periodic disturbance, but what is periodic motion? A motion which repeats itself after equal intervals of time is called periodic motion. A motion which repeats by itself after equal intervals and of that time, that particular time is called periodic motion. So what is the example of this periodic motion? So the motion of a planet around the sun, you clearly observe. For example, this is the starting point. So it is moving and it will reach after the same time of interval. You can observe clearly a motion which repeats itself after equal intervals of time, you can observe. So this is called periodic motion. So example, the motion of a planet around the sun. So what is oscillatory motion? You can observe, this is the left side, this is a tuning fork, this is the simple pendulum. To and fro are back and forth motion. You observe here in simple pendulum, you observe here, for example, from this place to this place, it is moving one side and it will come back. So this is fourth. You see, this is fourth one. So this is back one. You can observe clearly back and forth motion of a body periodically about the mean position. What is the mean position? You can observe here. So this is you observe clearly what I am saying. So this is center point. This is the equilibrium position or mean position. So this is the extreme point or end point. Extreme point or end point. From the end point, it is coming back and going forth motion of a body periodically about the mean or equilibrium position. That is called oscillatory motion or vibratory motion. So examples, first, vibration of tuning fork. You can observe clearly. This is, you observe here, this is the vibration of tuning fork. So second one, motion of a simple pendulum. Motion of this simple pendulum. So few terms in oscillatory motion. What is periodic time? You know very well. The time taken for one complete oscillation. You observe here, this is the simple pendulum, this is end point. So this is simple pendulum moving this side and coming to the same position. This is complete oscillation. You can observe here. This is the complete oscillation. Or we can take here, for example, this is the sine curve. So this is the origin. From this origin to this is half of the time period. So this is complete time period. That is one complete oscillation. The time taken for one complete oscillation, that is called periodic time or time period. It is represented by capital T. It is represented by capital T. So you can see here, so this is the equilibrium position. This is the end point. This is the end point. From this equilibrium mean position to end point, or this extreme position to extreme position and coming to extreme position, that is one complete oscillation. You observe here, that is one complete oscillation. So this is the starting point. It is moving this side and coming to the same position. That is one complete oscillation. So what is frequency? What is frequency? The number of oscillations per second or the number of vibrations per second, that is called frequency. So frequency is represented by nu, that is 1 by t. So this is the number of oscillations by time. The number of vibrations per second is called frequency. Frequency SI unit 1 by time, that is a second. So we can write second inverse. So the scientist name, that is Hertz. To remember respectively that particular scientist name, we are showing here second inverse, that is equal to Hertz. Frequency, the number of oscillations per second, that is called frequency. Frequency is represented by nu. Nu is equal to 1 by t. Nu is equal to 1 by t. So displacement, what is the displacement? You can see here clearly. So this is center point or equilibrium position, mean position. From this mean position to extreme point, this is the displacement you can observe here. So what is the definition? The distance of the particle or body or an object measured along the path of motion from its mean position, or simply definition, the distance between mean position and extreme position, the distance between O and A, that is called displacement. The displacement is represented by x. What is displacement in oscillatory motion? So the distance between mean position and extreme position, or the distance between O and capital A in this figure, or the distance of the particle or body measured along the path of the motion from its mean position at a given instant, that is called displacement. So what is amplitude? What I am asking, what is amplitude? So you observe in this figure, for example, you see here this arrow symbol point to this equilibrium position point, the distance between these 2 points, this is maximum displacement. This maximum displacement is called amplitude, or simply here also we can explain, this is the maximum displacement, it is represented by capital A. Or here also from this point to this O, this equilibrium position line to this maximum value point, the distance between O and A. Here also the distance between O and A, you can observe here also. The maximum distance covered by the body on either side of the mean position. Either side of the mean, this is P, so mean position. Either side of the mean position, or simply the maximum displacement in oscillatory motion particle, that is also called amplitude. Amplitude unit, we can write, what is the unit of amplitude in CGS unit? CGS, so this is centimeter. What is in SI unit? That is meter. That is displacement, that's all. So the maximum displacement covered by the body on either side of the mean position, that is called amplitude. Amplitude. Okay. Thank you. Thank you one and all. I am closing this video. Thank you. Thank you very much.